Hello, everybody. Last time we talked about radio waves, and remember we represented a wave by one of these little squiggly lines up here. Let me get us going here. So we're going to draw a representative of a radio wave. And I'm not doing very well on getting these things good and smooth today. Now remember, there's three characteristics about a radio wave. One is the frequency, which we abbreviate as an F, okay? And remember, the frequency is the number of vibrations per second. And the units are hertz. And I'm having trouble today. Okay, the next characteristic of a radio wave is the wavelength. And that was this funny upside down Y symbol called lambda. And that was equal to the distance between peaks. And then we talked about the speed or the velocity of a wave. Okay, and that was, we gave it the symbol C, and remember that was 300 million meters per second. Now today, we're going to talk about the relationship between these three things. All right, and we can we can write a formula that says the frequency of a wave is equal to the speed over its wavelength. Right, now this is a little algebra, and you guys are getting exposed to algebra, but we got a really neat little trick to help us remember this formula. First of all, this is an important formula. I'm going to draw a box around it, put a little asterisk by it. This will show up on your test, so you need to kind of remember this. Now, let's talk about the trick. We call this trick a magic circle. Right, and it's cut in three pieces, half, and then we cut one half again. All right, and in here we put C, the speed, and over here we put frequency, and over here we put the wavelength, lambda. All right, now commit this to memory too. Commit this magic circle. We call this a magic circle. All right, now let me kind of wipe off this thing and start over. All right, we'll get over here. Okay, so we're talking about this magic circle. Well, let's see if we got a magic circle here. All right, so we got this magic circle over here. Now, on your test, they're going to give you either the frequency or the wavelength. All right? So when you see a problem where they're asking you for frequency and telling you the wavelength or vice versa, immediately draw this circle over here. So let's have some examples of what you might see on a test. And they might tell you that the frequency F is equal to 14 megahertz. Right? And the M is the mega, which means million. Right? Now this little magic circle we set up works for when the frequency is in megahertz and the wavelength is in meters. All right? So if the frequency is 14 megahertz, then they may ask you, what is the wavelength? All right, well, come over here and draw this nice magic circle that we did. All right, now over here we told you that you got to remember that the speed of a radio wave is 300 million meters a second. All right, and in this problem they told you that the frequency is 14 megahertz. So now the wavelength, watch this, the wavelength, lambda, is equal to what's left in the circle. So it's 300 divided by 14. You get out your handy dandy calculator and you will find that this equals to 21.4 megahertz. Meters. So now you have done you've solved for the wavelength if you knew the frequency. So what they might do is they might give you the wavelength. Well, let's do another example. Let's assume they give you the wavelength and they say the wavelength lambda is equal to 6 meters. What is the frequency? All right? First thing you do is come over here and draw this nice magic circle. All right? And you put in what you know. Well, you know the speed of light, the speed of the radio wave is 300. You know the wavelength over here, lambda, which is 6, and the frequency is unknown. So you come over here and you say the frequency is equal to, watch, 300 over 6. And you get out your handy-dandy calculator, and you're allowed to take a calculator on the test. It is 50 megahertz. Isn't that easy? Isn't that simple? Right now, guys, if you don't practice this, if you don't go home and do this about 10 or 15 times, you won't be able to do this on the test. So we're going to do one more, and we're going to put a little trick question in here. So what if they tell you the wavelength is 70 centimeters? All right? Now I know that you guys have studied conversion between meters and centimeters. All right? So the trick question is typically you see this wavelength in meters. Today they're tricking you. They're fooling you and they're telling you centimeters. So the first thing you got to do is you got to say 70 centimeters equals how many meters? 0.7 meters. All right? So now you got the units so that this fits nicely into your magic circle. So you come over here and you draw your magic circle. All right? And we put in what we know. We put in the speed over here, which is 300 million meters per second. And we put in the wavelength is 0.7 meters. And we figure out what the frequency is. So we do that over here. We say frequency equals 300 divided by 0.7, and that equals to 428.6 megahertz. All right. I believe this is a concept that you guys can understand, but you got to practice it. So until next time, see you later.